Hi everyone, welcome to the next Quant Club. We have a special one today. Mike P is joining us. We're going to talk about our sort of incoming data release, which we're calling RAIN, and talk about the development of it, just different features of it, different things you can do with it. And so, yeah, I think it should be pretty interesting for all of you, especially since the data is coming out imminently. Mike, you want to start?
Yeah, the screen's fine. You can see the slideshow, right?
I see it, yep.
Cool. Yeah, so just I'm just gonna go through basically all of the important info to get you started. Gonna put the data out probably later today. But yeah, I want to go over some of the highlights. So first of all, just the overview. There's 666 new features. And now there's a total of 2,132 features in the data set. There's also 12 new targets for a total of 48 now. And then a fan favorite, there's feature groups coming back, like charisma and intelligence and all those things from V2, plus a couple new ones. So one of the kind of the key thing about the RAIN data release that's interesting is that these new features are they're time series transformations of existing features that you've already had. So yeah, we've talked a little bit about how these were made before, but yeah, MDO was the mastermind behind these. You want to remind them how it was made?
Sure, yeah. So basically the idea is at the present time at a given era to have some sort of context of previous values of the feature. And these were created in a few different ways. The one where we basically fit and learn sort of filters on historical values of the feature, and the filters were learned in just sort of a linear way. So they're learned in such a way that they are combined with the sort of existing features. So just like the point in time feature and the filtered feature are all present in the sort of final model that it's a linear model and that's trying to predict the target. So these features are, there's a couple other sort of regularization and sort of things we optimize for to make these features good at too, but they're basically just linear filters on historical values of a feature. That's sort of part of the RAIN features. Some of them are somewhat more exotic time series transformations. We basically used the TS-Fresh library and kind of looked at some of the transformations in there and used some subset of those transformations that seem to be pretty good. And there's and also another sort of simple transformation, a time series transformation, just sort of looking at historical values compared to the current value, like comparing the whether or not a feature is like below or above the median over a period of time in the past. So these are all kind of standard time series type transformations that you guys can't really do because you can't match basically a stock's identity across time. And you need to be able to do that in order to create these time series transformations, obviously. But so we sort of try to do all of them that basically seem to work pretty well and that would be good for building models. And there's, I mean, obviously a huge number of possibilities, and we looked through way more than we're actually releasing, and we're kind of releasing the best of what we found. But yeah, the point Mike mentioned here is in sample. These were for ones where like the filters were fit and where we were sort of evaluating them. They were all sort of only done with data up to era 575. They're not hugely overfit at all. Like I think you'll find if you use them in that sort of training period, they don't seem to be particularly better than any other features. But you should just sort of know that they were created using that data. And so everything past era 575 is completely out of sample. No data past that point was used in the creation of any of these features. So that's an important thing to keep in mind. We don't think you'll have any problem with them being overfit, but it's good to just sort of evaluate that for yourself. And it is only sort of this new RAIN feature group that has this property that they are sort of fit on some subset of the data.
Yeah, and yeah, so an important thing is we expanded these feature groups, which are in the features.json, especially to let you isolate the RAIN features if you need to. So if you download the Parquet and download this features JSON and just get all the ones that are listed under the rain feature set, you can know exactly which ones were actually in sample up to era 575. But these feature groups are interesting in a lot of other ways. Like, first of all, one thing, we still have small and medium. Small has changed a bit. Small features are basically like the most important features if you were to fit a model over all the training data. Just for the record, that's how those are made. There's at least now a lot of people just wanted like an all feature set, so it's easy to get all the feature columns in one place. But yeah, the interesting part is these sort of like intelligence all the way up to Serenity groups. So if you've been here for a while, then you remember the V2 dataset had all the features were called like feature charisma, feature intelligence, feature strength, and so on. And these kind of represent features which are kind of related in some way, like they kind of are likely to kind of move in the same directions, and kind of they're just a little bit related. So yeah, India, what do you think people should do given this new knowledge?
I mean, people had done things like basically leaving out whole feature groups during training. So you could make a model where you remove, let's say, the charisma features, or some subset of like multiple feature groups, or just using some like just training just on like the constitution features, or yeah, I mean, that's a really great way to make models that are very different. Like if you leave out whole feature groups, your model won't be able to learn some sort of uh, types of things that it might if you were in there, and it'll have to kind of rely on the other features to fit the data. So it's a sort of nice way of being able to make a greater diversity of models. Yeah, I mean, also like for neutralization, you potentially neutralize to some subset of them. Maybe you think some of the feature groups are particularly risky, and you want to like have very low exposure to agility, for instance. I'm not suggesting anything in particular. I'm just saying things you could do. So yeah, there's lots of different things that you can like combine and mix up, and just these are sort of handy groupings because they do sort of actually capture some meaning of what the sort of features are.
Yeah, I mean, I can actually give a little bit of info about like Serenity is like kind of a unique set. Serenity is a group of related features that are they're kind of things that the target is like more neutral to. Which what you'll find is that if you were to plot correlations of features versus the target Cyrus over time, whereas agility and wisdom and constitution and all of these feature sets, you'll find that sometimes they have a lot of correlation with the target, sometimes they have very low correlation with the target. What you'll find is Serenity consistently has very low correlation with the target, and it's often like a good thing to neutralize to. And then yeah, just kind of some internal leads we've had are we kind of think like charisma and agility seem to have kind of contributed to the most recent drawdown quite a lot. Um, in some cases, yes, some cases, no. We don't think it helps to like completely neutralize to these feature sets or anything. But if you are looking at a first experiment to try and figure out how to make use of these feature groups, trying to see if you can do something different with agility or charisma in like the last 100 eras would be an interesting way to go.
Cool. Anybody have any questions at this point? No? Okay. Should we keep going, Mike?
Yeah. As you guys know, we always are including more targets. So in this set, there's 12 new targets, and these are like they all have very different combinations of risk controls. I don't think it's any actually new risk controls that weren't in targets before, but it's just new combinations that weren't really explored in any of the previous targets. So I like to think of these as sort of interpolating between all the existing targets that we already have, kind of filling in some gaps. So if you're a person that really likes to just build a model on every single target, and then ensemble all of those together, there's sort of no way these don't help those types of models. And there's one that's a little bit different. There's 5 of them. It's like Alpha, Bravo, Charlie, Delta, Echo, which are these like kind of strict interpolations between other targets. And then there's one called I think it's called Jeremy, which is like kind of it's like Jerome, which is an old target that we actually like quite a lot. It seems like when you build models on Jerome, it ensembles really well with targets both on like Nomi and Ralph and Cyrus. And this new one has like a little bit of the newer technology, but so it's supposed to be the same thing as Jerome, just with a little bit of the newer technology built in. Should be a little bit better. So if you have any models that are like, the old Sunshine model, I think was like Jerome and Nomi. Maybe if you just replace Jeremy for Jerome, you'll see a little bit of an improvement. Okay, so one of the kind of infrastructurist changes we've made is the way we do int8 stuff. So in the past, there was like there's like the default version, and it was just called, train.parquet. And it was all float data, and it was really big, and everyone's computers crashed when they tried to load it into memory. And there's also an int8 version, which was a good bit smaller, but it was this really weird data type of like capital int8, which is like a specific pandas. There's like a pandas specific data type that allows NaNs, because NaNs are like a float data type. You can't have them in an int column. So you had to basically load in the data with this capital int8, which took up more space. And then you had to fill NAs in some way because LGBM can't deal with capital int8. Anyway, it was kind of a bit of a mess. And we were trying to handle too many trade-offs by giving 2 data sets. But now we want to just give out 1 data set, and we think this is sort of the best trade-offs of all the different variations. So what we've done is it's just the lowercase int8 that we're all familiar with. It's sort of like the smallest data type that you can pass into LGBM kind of freely without it complaining about anything. The total data set size ends up being like 1/3 the size of the full Sunshine, even though it has more features and just a lot more targets and columns. And it's even 2/3 the size of Sunshine's int8 because it's this lowercase int8 type instead of capital int8. And the code is simpler because you don't have to manage converting types and filling NAs. So it does seem a lot better all around. The main trade-off is that one thing we did with Sunshine was that if there was an era where typically we just fill in NAs for data, but what we did before with Sunshine is there are a lot of features that don't even start, like the data doesn't even exist until era 400, for example. And we just filled in those features with NA for eras 1 through 399. And the point of that is to not give basically random values. It's better to let the users know that this data doesn't exist and it's not real. And you can handle those missing values however you want, whether that's passing the NAs directly into a model and letting the tree split on that or ignore them, or trying to interpolate them using other data. And so that was kind of a key idea, to let users handle this missing data the best that they can, instead of us kind of hiding it from them. So what we've done now is, instead of just filling it in with NAs, we fill in the entire feature with 0.5s for an era if it's missing. So the downside is, sorry, go ahead.
It would be 2, right? Because these are
sorry, yeah, it's ints, it's 2s. Filling it in with 2s, the middle value.
Yeah.
Good catch. So the nice thing about this is users can still see which features are missing. If you can just check for whichever features have all 2s for an era, and that's just missing data. But the nice thing is you can just leave it as it is. That's kind of our like recommended way of handling that. Or you can just mark them as NA, so let the tree handle it, and so on. So there's no information lost. And power users can still handle these situations however they want, but not at the cost of making the code much more complicated if you don't want it to be. And do you agree? Do you think like leaving it as 2s is fine, or do you think people should fill them as NAs if they can?
I think models will work differently. I think it's reasonably safe to leave them all as 2s, but I think models might learn different things and might work better if they're actually aware of the NaNs. But yeah, you're going to have to change the data type and fill those in with NaNs. But I think it's definitely worth experimenting with. I mean, I think just in some of my experimentation, some of the feature importances looked pretty different when you left the NaNs in, because some of the features that had a lot of NaNs didn't look important to the model because they had so many kind of like dummy values filled in. But once the model knows there's NaNs there, it doesn't have to sort of consider them at some of the time, and then those features actually seem more important. So yeah, I think it's definitely something people should experiment with, but it's not terrible. It's definitely not terrible to just use the out of the box filled ones.
I think, I mean, I'm just reminded this, it might be an especially important data set to care about this on, because the rain features, because they're all time series based, I think they'll just all be filled in with twos for like the first, 30 arrows or so. And a lot of the features beyond that, just due to the length of how long the time series transformation is. So there will be a
So
lot of them.
so Mike, someone's asking a question. I think let's clarify this a little bit more. Did you see the question?
Yeah. So if the mid value is 2, how do you determine if the value was NaN or in fact 2? So yeah, the indicator that it's NaN is that the entire era is 2.
For that feature.
For that feature. Yeah,
Yeah.
exactly. So if any other twos, if it's you'll see if it's a real value 2, then you would see that there's other rows in that era where that feature is 0, 1, 2, 3, and 4. So that's the difference.
So yeah, you could do a simple sort of pandas thing where like if all equals 2, uh, then it's you can set it to NaN, that kind of thing.
Yeah, so this is Wiggle Muse. Just to clarify, like the difference between the current NaN system, where so if there's a NaN, it's always a constant column, which I think maybe not everyone remembers, but so there's never just a random NaN in a row or something. It's
Right.
always the entire column in that era. So you're always looking for a constant column. And in 4.1, it was obvious because they were NaNs and they would mess up your model or crash it or something. So this, you're looking for twos in a constant column in an era, but there may be other eras where the data is filled in. So like I do everything era based, so it's easy for me to distinguish those. But if you're throwing all of the eras together, now you've got these big mass of twos for certain features especially in the earlier eras. And so I don't know, it seems like you might want to put a flag on those or something where we could just like pick up an indicator row or something that would just tell us the columns that are constant, and we wouldn't have to scan for them. And there are a few eras in the middle where it just randomly like I was just redoing some data because you changed it on 4.1, and I noticed that era 894, just out of the middle of something, has got a bunch of NaNs in it, but the ones adjacent to it don't. So you do have
Yep.
to watch out for that. And my follow-up question is, do you expect to ever see NaNs in new live eras? You said possibly we might run across them, but we never have so far.
Yeah, it's still a possibility. I mean, it's about as common as them being missing for those 2 random or 1 or 2 random eras, like 894, you said, where I think there's maybe like 10 features which are NaN there. Maybe once every couple of years we expect that, but yeah, we haven't had it happen in live data yet.
And one other question, sort of not related to this, but how does this data set compare to 4.1 aside from this NaN issue? Are all the features that are not new the same, identical? If we just subtracted the rain features, would we get 4.1 again without the NaN issue?
Yeah. So we removed a fair amount of features that were in Sunshine. So what you'll notice is the number of features that were in Sunshine, which I forget the exact number, 1600 or so, plus 666, the new features, you'll end up with a higher number than the total number of features that are in this data set. It's because we removed about 100 features that were previously in v4.1.
But the other ones are the same. Right?
Yeah, the other ones are the same.
So no existing feature has been changed, but there are some features that are just gone.
Right. And well, the sense that they've been, so one of the things I've done is I've gone back and updated the Sunshine data set, historical data, with kind of the new rain version of them. Do you know what I'm talking about, Wigglemuse?
Yeah.
So yeah, I mean, just to give everybody else some context, I did yeah, there's a handful of features basically in Sunshine that were had like a bit of a consistency issue where, you know, in training data and in validation and live data, they were kind of generated slightly differently, which is very bad for models. Obviously, if it's predicting on kind of a different definition than it was trained on, that's very bad. So we discovered that in developing Rain. So what I've already done is gone back and changed all of the Sunshine historical data to fix that issue. And so now they'll match perfectly with the Rain features.
Someone had suggested that we could have used -1 to mark the NaNs. I actually think using the middle value is probably better if you just wanted to just train on it with them. So basically, we sort of filled it with 2, so that it should still work pretty well in models. I mean, filling it with a sort of the middle value, average value, is a pretty good way to fill in missing data a lot of the time. So we sort of just filled it with something that shouldn't disturb a model too much. -1, you'd probably, if we marked it with -1, you would definitely want to do either remove them or fill them with 2s yourself. So we opted for filling it with a sort of middle value so that you could just sort of use the data out of the box.
Yeah, if you do -1, it's like it starts thinking -1 is closer to 0 than it is to 4. So that's kind of scary.
Yeah, Thomas said exactly what I just said.
Okay. So the new data set has like new example predictions as well. If you download v4.2/example predictions.parquet, then you'll get something like this blue line. And it's actually a lot simpler. Like the previous Sunshine example script was kind of complicated. It trained on like 6 different targets and ensembled them together and did some half feature neutralization. So it's kind of complicated. But now it's pretty simple. It's just target Cyrus. It's all the features. It's a 20,000 tree LGBM. It does walk forward training is like the one kind of tricky part. But it should be actually easier to do this because the data is actually smaller with this new int. We found that instead of using the small feature set on the Google Colab, for example, we can use the medium feature set and get away with it. So the idea is, yeah, use a good target, use all the features, and use a big model, and you should get something pretty good right out of the box. What is the frequency of walk forward training? It is retrained every 156 eras. So the first 156 eras are training, and then you predict on the next 156. And then after that, you'll train on whatever, 2 times 156 and predict on the next 156. So it's done like that. And of course, there's an embargo of like 12 errors in there as well.
And yeah, in the example code, you also have example code for putting NaNs back in, right? Like Wigglemuse was asking for maybe like a index into the NaNs. I think we're dealing with that just by having sort of code you can use to put the NaNs back in if you want, right?
Yeah, that's a good reminder though. I haven't actually done that yet. I haven't actually added that to the example script. But I will add some code that just says for this era, this is how you get all the missing columns, all the constant columns.
Yeah,
Okay.
I would just include a function,
Yep.
you know, find constant columns.
Yeah, totally. Yeah, the nice thing is, look at how much better this performance is. The Sunshine example is so complicated. It's all these ensembling. It took forever to run. Rain, like it runs faster. It's It's kind of much simpler and easier to understand. The code is nicer, and you just get better performance. So I think it's a really nice win.
Yeah, we thought this was all pretty cool too, because these are just transformations of existing data. There's no like actually sort of new data that goes into this. This is just using data that already existed sort of in new ways. And so it's nice that yeah, you can get something such a nice win just from existing data.
What's with the 20K trees? Can you explain why more trees help? We've kind of always thought 20,000 trees was better than 2,000. Like we put that in the comments of the old example script. But yeah, what do you think about? Does more features mean that you should have more trees? Michael, what do you think?
It does, yeah. I mean, there's a so I mean, I think like especially when you have this call sample by tree parameter, if you set that pretty low, if you actually look at the predictions from each tree separately, you find that they're like virtually uncorrelated. And so having a bit, so every time you fit a tree, it's basically bringing your predictions closer to the target. But each tree itself is like almost completely uncorrelated, and so you have this ensemble of like tons of uncorrelated things. And yeah, I mean, basically just having more uncorrelated things you're averaging together that are all kind of pointing in the right direction on average helps. And yeah, we've just sort of empirically found that often more trees helps. I mean, we've done experiments up to like 60, 80, 100,000 trees, and seen, I mean, decreasing benefits. But yeah, even sometimes 60,000 could be helpful depending on your hyperparameter settings. But yeah, I mean, it's adding more trees is kind of just like also kind of smoothing your space. I mean, you're kind of interpolating this huge high dimensional space with these little boxes that each tree is creating, and more trees is kind of making your interpolation of that space a bit smoother. It's another way to think about it.
Do we ever see any fall off? Did we ever get to a point where we trained on 100,000 trees and it was just worse than 20,000?
I think Marx did find some of that, but yeah, I mean, there's always hyperparameter trade-offs. You could probably find a set of hyperparameters. Like if you lower the learning rate, for example, you probably won't see that.
Yeah. Okay, here's the bad news. Prepare for the booze. So we're finally deprecating V2 and V3 datasets. There's kind of a lot of reasons. Some of you even predicted this in Discord and Rocket Chat and so on when we were maintaining all of these datasets, saying, yeah, I doubt your ability to maintain all of these. And those doubters were right. Basically, we spent a lot of time internally like trying to maintain these old pipelines, because V2 and V3 datasets use completely separate pipelines from the shared one, the shared modern one that V4, V4.1, and V4.2 are all using. So we basically just end up spending a surprising amount of time just trying to make changes and not break old data sets. We know a lot of people have great models that they're still submitting on these old data sets, and we don't want to break those. But it's just gotten to the point where we have to just cut it off at some point. So October 9th, we're going to discontinue those data sets. So one reason is engineering. The other one is performance. At this point, so this plot is showing like from bottom to top is V2, V3, V4, sunshine and rain. And yeah, the bottom two data sets are just really quite a lot worse now. Yeah, so it's, if you do have a great model, I know some of you are going to say, you know, my best TC model is on V2 dataset, and I've been manually downloading the zip every week and submitting it or something, which is awesome. Like that's one of our favorite things about releasing new data is like, well, we hope people keep submitting on old data sets because it's going to ensemble well and it's going to add a lot of diversity. And in case there's something wrong here, we kind of have a hedge because people are going to figure it out and keep using old data sets. And that's kind of why, that's a big reason of why we keep these V2 equivalent features and V3 equivalent features around, so that you can replicate your old models that you like if you just really like these data sets. So yeah, hopefully you can make use of those and transition easily. Any boos? I want to hear some boo. It'll make me feel better if I see some boos in chat, honestly.
That plot is very compelling, Mike. I don't think I've seen that exact plot before.
Yeah. It's nice how I like how the rain one is the only one that's still going up in the last, everything's going down except for rain in the last few weeks.
Yeah.
It's kind of nice.
It's crazy how kind of even the differences are to me.
Yeah. Trying to think if there's anything else to say about this. I mean, one good news is if you have models that are on V4, Sunshine or Rain, it'll be very easy to support those for a long time because they all share the same pipeline. So yeah, it should be several more years. Kind of have this slide as like an open forum of yeah, what are the first things people should research when they're downloading this data set? What are the first things they should try? I included, like, we've talked about removing, including, neutralizing feature groups. I mean, one thing that we've kind of just discovered internally is neutralizing V2 data looks really interesting.
Yeah. Basically, yeah. I think you did this. Basically, just train a model on the new data set, but then neutralize it to just the V2 features. Actually made the performance quite a bit smoother over the predictions, and didn't. I mean, your correlations after doing it are lower, but like they're kind of in the range of like what you were getting with like Sunshine before. So you go from like 0.03 to 0.026, which is still quite good, but like you're with a sort of much higher Sharp. So yeah, there's something interesting about the V2 feature group, about as a sort of neutralizing set. I mean, they're all kind of like more basic features, and so yeah, that we were kind of surprised because I mean this recent period has been hard on a lot of models, and we've been doing a lot of like work and trying to figure out what is going on, how can we make things better. This is one of the sort of simple and most surprisingly good things we found.
Just in general, neutralizing two different feature groups and removing and including them is, it's kind of like a really interesting area I think people should spend more time on. And it was maybe way too hard to do in the past. Like if you didn't have these feature groups, then what you might do is try to remove randomly 10% of the features, or do this kind of column subsampling. But what you'd find is you'd remove one feature, but there's still 4 others that look almost the same as it. So your model doesn't care that much. It's very robust to if you remove a few features, and it doesn't learn new things. But the nice thing about these feature groups is if you remove a whole feature group, there's no other feature that can kind of mimic what you had with that whole group of features removed. So your model will have to just learn something totally different and find ways to compensate for not having that entire feature group there. So that's the type of thing that might ensemble a lot better with each other than if you just try to remove 10% of features randomly at a time or something like that.
Yeah, and I think you'll find like the performance hit from removing a whole feature group isn't that big, but it's the correlation with like a just baseline model is quite a bit lower.
Yeah.
Which is like exactly what you want for ensembling.
It'd also be, I'm sure people will have these sort of, we had someone in the past that was called like lack of intelligence, lack of charisma, and so on. And it was basically, he had all these canary models running and people would look at him on the leaderboard and say, look, lack of intelligence is doing really well lately, indicating that the intelligence features are all kind of having a bad period or a rough patch, or they're going the opposite direction that they did in the training data. So yeah, I'm interested to see people running these sort of canary models to try and understand what's going on in these different feature groups.
Are we opening up more model slots for people to experiment with this, Mike?
Yes, I'm so glad you asked. We're gonna go from 75 to 100. I got approval. I ran it by the higher ups. They said our AWS cloud can handle it. So it's gonna be 100 model slots now instead of 75.
We only have 70 now, so
Okay,
uh,
maybe I can approve the last 5 to get us up to around 100. Yeah, there was some discussion in Discord about how to use the new model slots with respect to staking, like stake management and stuff. Wigglemuse, were you the one saying they should hold out 10, or is that Boar maybe?
that was Bohr, and he's right. And staking, I'm actually unstaked right now because I just took all my money out from moving. So now I'm using all my slots for experiments, and I'm going to need some for staking again. That will be fresh, I guess. But yeah, if you're staking, if you're making all these models, you're going to want to stake a lot of different models probably, and it's a huge pain to like have a model you're tracking, which you might change, and then stake on it as well, because as soon as you want to change something, that stake is sort of stuck there, and then it makes research a lot harder. So if you do have models that are only for slots that are only for staking, that makes things easier, but then you're using up those slots. So stake management, come on, guys. That's what we all say every time, but
Yes.
we still mean it.
Yes.
So on the topic of taking away feature groups, and I think I was just thinking because like Mike was just saying, or Michael Oliver was just saying, when you take away a group, it doesn't change the performance of the model as much as you think it would, but it will change sort of the character and correlation of that model to other things quite a lot. And this goes back, I think, to something like he posted a paper a long time ago that was basically about like simplicity bias, I think it was called, something like that. And I think you've got, a group of features that's maybe just slightly better than another group of features uh, most of the time. And so when you're training and you're optimizing on what, the model learns, it always picks these slightly better features and it biases towards those. And when those tank, so when you take away those features, you're not like losing some giant thing. You're just going down a tiny tier to these other set of completely different features, and it finds a completely different way to learn something. So that's enormously valuable, I think. And it's not, in other words, you're learning a completely different model that you wouldn't even know about in a way because you're optimizing. It's picking different features now, but it's making a different
Yeah, that's absolutely
direction.
true. And actually, if you can see that in feature important stuff, if you train models on some features that are very similar, a lot of times the one that's like slightly better than the other, even though they're very similar, will have much higher feature importance, which is a bit odd. But if you just remove its ability to access that really good one, it'll really put a lot of weight on the one that's similar but slightly worse. But yeah, I was actually just thought of one more thing we were talking about model slots. Yeah, we're kind of working on a new target internally it's kind of deep in the research phase. But yeah, you might, I don't know, like, yeah, you might want to wait for training, like maybe in a month or something. There's a brand new target that's quite a lot different, and just better aligned with really with what we're going for. I don't think you should actually wait. Who knows? These internal targets always take a lot longer than we think they will. But maybe save a couple of model slots for when we drop the new target in a month or so. Because I think it probably will look a bit different than Cyrus.
Is
Just
there
an
any?
FYI.
I think people are wary of changes, and you don't have any more like plans to change the scoring targets anytime soon, do you?
No, I mean, it depends on how this. None of the targets that we've given out now are like better than Cyrus. We think like Cyrus is our main scoring target. There's no plans to change that. But yeah, I can't promise that in like 3 to 6 months there won't be some other target that we like.
And there's also, I mean, just a heads up on possibility of things that could happen. We could use the same scoring target, but we might change how we score on it. Like we might, if your correlation, instead of just like a correlation of the Numerai correlation, like a sample weighted Numerai correlation could happen, where you care about some samples more than others. And we would give everyone all this like historical sample weights, so you could use models. You could. I'm just saying an example of something that could happen, even if we didn't change this. I don't know if this is going to happen yet. It's still in research, but these are things we're looking at. But yeah, we're basically just trying to like, because there are stocks that we care about more than others. There are stocks that have more liquidity and we can trade more, and so it's more important for you to get certain stocks right than other stocks. And so we could reflect that in the scoring function with like sample weights or whatnot. And also historically, we could give you like sample weights for everything previously. Yeah, these are examples of things that could happen. There's we don't have a timeline for these things yet. They're still in research, but just things to think about. I mean, sample weights are pretty easy to use in a lot of standard libraries. If you have your own custom things, you might want to think about how you would incorporate sample weights into them, but it's usually pretty straightforward.
Correlator says you realize we'll have to retune all models with a scoring target changing. Yeah, that's yeah, we're not changing it just for the sake of changing it. Like one thing we would want to see with a new target is that like this most recent drawdown almost completely goes away. That's like one of our goals. We've done a lot of research trying to figure out why the May period was like so bad for models. It's kind of a big burn period. And we're trying to figure out kind of how to resolve that and how to give a target that won't let that happen. Or we hope that it won't let things happen like that. But yeah, retuning is painful. I mean, and trust us, internally, it's like we're not happy that things have to change, but it's because it's based on models doing badly. It's like, how can we kind of fix these problems, and help you guys get better scores and better payouts and things like that, as that's aligned with us. So yeah, we're not changing it just because we want to force you guys to all change everything you're doing. It's for benefits, hopefully.
The correlator is saying the next drawdown won't look like something that's happened before. I mean, yes and no. Like we're not trying to like overfit to this drawdown. We're trying to like discover general principles that apply to this and previous drawdowns.
Here's what I would say about changes, especially that affect staking in any way or scoring, is that you should have a calendar that, every time you make one, there should always be a certain amount of time before the next one, because even good changes cause some subset of people to stop staking their models. They're right, and they're going to take them out of the meta model. They're going to like, okay, I'm going to wait and see what's on with this. I'm going to wait and see what's going on with this. And if you're just changing all the time, then you're taking people out of the model every time you do that. So if you do it too often, and the rate of sort of replacement of good stuff from the change isn't quick enough, you're shooting yourself in the foot just by the rapidness of it. So think
For
about
sure.
it.
Yeah, I think we could be better about putting out like a guaranteed calendar. I think with scoring changes, I think it was like Nomi it was just like the Nomi scoring target for like 2 years or something. And now, yeah, we kind of expected Cyrus to be a lot longer. It really depends on, and we really don't want to make changes. We know it's like painful whenever you have to like retrain models or scoring. You have to reevaluate your models because the whole scoring and payout basis has changed. We don't take those things lightly, but yeah, we do kind of have to just trade off. If we think we found something that just really, really helps, and we almost have like a flaw in our strategy, which is kind of what our target is representing, is like our whole strategy. We do have to just trade off how valuable that change is with how painful it is, and kind of, yeah, it's all kind of a balancing act. Can you share any insight into what you think may have been the cause for recent drawdowns? I don't know, like, yeah, one of these kind of the things that we've talked about a bit are like some of these features do seem like they've just gone in the opposite direction of all the training data, in some sense, but it doesn't account for all of it. This sort of sample weight scoring thing that MDO was talking about is kind of another, like, we found that some stocks, even though if we predict them correctly, it's not actually that valuable to predict them correctly because they cost too much or something like that. So that's kind of a smaller factor, but we haven't found anything that's like a smoking gun, really. It seems to be a combination of things to contribute. Michael, do you have anything to add there?
Yeah, I mean, the largely it's just like the average model performance. I mean, you guys saw this in Burns, was it just was pretty bad for a while, and there and the models that did okay didn't have a high enough stake, and so for the meta model was pretty exposed to your guys' models doing poorly, and that just, I mean, the market's just behaving differently, and you can see it even in the correlation plots. Just like the recent periods for like the models were basically flat or down in kind of unprecedented ways, like ways we didn't see over the previous like 10 years of training data or like validation data. And so, yeah, I mean, if when the models don't do well, like it's hard on the fund. And what causes it? I mean, yeah, basically exposure to features that are reversing, just like, I mean, yeah, sort of combinations of things that haven't happened before. I mean, we're always kind of in extrapolating in this crazy high dimensional space, and sometimes you're just in a part of the space that you've had, it just works differently than your extrapolations expect it to.
So the correlator says maybe get rid of scoring target, TC all the way, and more insights how to improve TC. Yeah, I mean, so a couple of thoughts on this. One is that, yeah, the new target we're working on, one of the kind of criteria that we want to be true is your percentile score in the new target should be extremely similar to your TC. The whole goal of the target is to have it be extremely aligned with our actual optimization that's taking place, actual portfolio construction, such that these things are much more similar to each other. And it's not a surprise that your TC is high while your correlation is low, or vice versa. Getting rid of correlation altogether is kind of hard, just because TC tends to be, it's close to like zero sum in practice. It's not designed that way or anything, but it's just, it tends to be that way in reality. And that's not the best situation, I think. So it's nice to just have some true north that says, look, if you do well on this metric, you're going to make money. So I think always having a combination of correlation and TC is good, but hopefully they can be, at least correlation will be a lot more predictive of your TC. And so basically, to answer to your point, more insights how to improve TC, the answer will just be have a much higher score on the actual scoring target, which it doesn't seem to be completely true right now.
Any other questions?
Yeah, it would be more like the core, your TC would be, so he says, how can TC be close to zero sum if core being high is equal to TC being high? It'd be like your core percentile rank. Like if you do better than everyone else in core, then you would have high TC. That would be kind of closer to what it is. And the other thing would be TC would still kind of have an element of correlation with the meta model. So if you could have really high correlation with the target and low correlation with the meta model, then your TC would be high. So there, yeah, it's not like exactly 1-to-1. There's still some other elements that go into TC, but at least you would have some clues on which direction to take to improve your TC.
I think in the past, when we raised slots, there was also occasionally a raise in the payout factor cap. Any thoughts there?
I haven't talked with anyone about that, but we'll ask.
Yeah, I mean, one thing to also note is like with this new data, your average core should go up like pretty. Like this is a pretty nice thing, so that should hopefully increase your core payouts as well. But I don't know if we're going to change any of the caps. But yeah, I would expect people's average correlation scores to go up and therefore be able to get higher payouts from core. And obviously with TC, because it's sort of how you're contributing in the ensemble, the people who sort of jump on the new data the sooner and kind of get the most benefit from it sooner will probably get much higher TC yeah, from that.
One thing that's also is like, yeah, if with these V2 and V3 deprecations, it's like if you're one of the people that's willing to fight through the change, you're kind of getting rewarded for it, because the payout factor might increase if other people just kind of give up and say, oh well, it's changed, I'm not going to stake anymore. Maybe that leaves a little bit more available for those who do adapt. So that's a nice little incentive for putting up with all of our changes.
Is everyone here already on like the newer data sets? Does everyone already abandon V2 and V3, the ones that are being deprecated? Is that why we're hearing no complaints?
Yeah, maybe no one cares. Maybe this is all in my head. Maybe I've been battling demons in the back engineering rooms trying to save these data sets for years. Maybe no one cares.
People seem to have a soft sweet spot for V2. I haven't heard much about
Yeah.
V3. I actually thought V3 was gone already because you said you were getting rid of it, and I don't have any V3, but V2 people keep saying, oh, I just keep doing V2, and they've been asking for V2 to be in the model uploads even, et cetera, et cetera. So it's just a lot easier to deal with, I think, for some, just because of the lack of limited features. But
yeah, V2 is the one that's a lot more painful to delete than V3, just because it's been around forever. I think I even said in the past, I was like, yeah, V2 we're going to keep around as long as possible. Yeah, but hopefully the V2 equivalent feature set is helpful there. And once you get model uploads going with it, you can trust that it'll be there forever.
Yeah, the V2 equivalent should be as good as the V2. You just might need to retrain the model.
Yeah.
Thomas says V2 is good when market is bad, uncertain.
One of the things that's interesting is when the market is bad and everything's going down, like random noise seems to be better than whatever you train. So a lot of times I'll be like, I'll make a model and I'm like, oh, look, the drawdown isn't as bad. And it's like, oh, it's just because it's like more random. So you have to be careful of those kind of things. But I do agree, like, yeah, V2, there's some simplicity to it, and it's like a lot harder to make big mistakes with it. FNC V4 features.
The JSON file.
Yeah, interesting. I'll double check on that. It might be that I forgot to copy those over or something. I'll make a note.
Anyone have any other questions? Yeah, Mike and I will try to hang out in Discord to answer any more questions there.
Last one is data in API now updated. Yes, it is. It's good to go.
And some people have already gotten it through the API. Is that true, Mike?
Yeah, it was supposed to be. I was like, well, maybe 1 or 2 people will see it, but then of course 1 person saw it, We have like, yeah, Numer Blocks is now updating their third-party software to handle the new data before it's announced. It's been a bit more people found it faster than I expected them to, but it's cool. Yeah, well, official announcement will be pretty soon. And it'll be updated on the website, and example scripts and all those other things will be out there, and links to it in the forum post. So
will there be a new grid search for the new data? What do you mean exactly? Like for the hyperparameters for an example model, or?
Yeah, there's not really any new grid searching going on here. Maybe we can clarify more in the Discord after if there's a more specific question there, but I think we're out of time.
There was a forum post that had the best parameters for the sunshine data. I think it was titled,
I see,
massive grid search.
Oh, yeah,
something like that.
Yeah, Mark posted that, right?
Should we get Mark to do that again?
I don't know. Yeah, no, we haven't done any grid search on this. I don't know if we will anytime soon. There's no plans for that. But if we do it, we'll post it. Okay. We ready to call it?
Yep. Yeah. Thanks everyone for coming. And yeah, please ask more questions in Discord. We'll try to answer them as we can. And yeah, great to see everyone. Thanks a lot.